Welcome back to the video series on integration and differential equations. Today we're going to look at basic trig forms and we're going to run through 10 key formulas. I think we should do these in 3 batches just so we can look at the formulas a bit more closely. First up, we've got the integrals of sine u and cos u with respect to u. Next batch of formulas, we've got 4 integrals that give us our 4 basic trig functions, tan u, secant u, cotangent u, and cosecant u. And notice that the bottom 2 formulas here give us negative functions as a result. And finally, the last batch of formulas, now we know how to integrate the 4 basic trig functions, tan u, secant u, cotangent u, and cosecant u. The best way to get familiar with these 10 formulas is to do some practice. So let's try an example. So let's evaluate the integral from 0 to pi over 28 of sine 7x with respect to x. Well, a tip for all of these basic trig forms, typically we would substitute u equal the angle inside the trig function. So in this case, u equals 7x would be a great choice. du would be 7 dx. And if we then look up at our integral, okay, well, we could rewrite the sine 7x now as sine of u. So that's great. Sine of u is a way of rewriting that. And then we would ask ourselves, well, how can we rewrite the dx? So we need to add one more line here. To move from 7 dx to dx, we'll be dividing by 7. So du over 7 is another way of rewriting dx. Now, since this is a definite integral, we need to deal with the limits of integration as well. When x equals 0, u is going to be 7 times 0, which is 0. And when x equals pi over 28, u is going to be 7 times that, so 7 pi over 28, or more simply, pi over 4. Great, so now we're ready to rewrite our integral. So let's say the original integral is equal to the following. We'll be integrating from 0 to pi over 4, and what we're integrating, sine u, times the dx is going to be rewritten as du over 7. So let's put that 1/7 out in front. Great, so now this looks like a basic trig form. We can refer to our formulas over here. The integral of sine u is going to be negative cos u. So we've got 1/7 times negative cos u, and that's going to get evaluated at pi over 4 and then at 0. Okay, so let's plug in here. Cos of pi over 4 is 1 over root 2. We've actually got the negative version of that, so this is negative 1 over root 2. And then we're going to be subtracting off the value of negative cos 0. Well, cos of 0 is 1. Negative cos 0 is negative 1. So we've actually got a double negative going on here. You could say plus 1, or you could say minus negative 1 here if you like. Okay, so that's one way of giving your answer, but it would look a bit nicer if we do some rewriting here. So first thing I'm going to do is put the positive term first. So let's write 1 minus 1 over root 2. And as we do that, let's create a common denominator of 2. So let's express the 1 as 2 over 2. And then we'll move on to the 1 over root 2. We're going to rationalize that. Let's multiply top and bottom by root 2. So that becomes root 2 over 2. Okay, so that way we can create a final denominator of 14. So we've got this 1 over 14 out in front, and then in the brackets we've got 2 minus root 2. So both answers are correct here, but it's a little bit easier to deal with this simplified form. Great, so we'll do some more practice in our next video. See you then.